Welcome to another math video. So we are talking about equations of lines, and we're going to talk about some special cases about lines. Mostly focusing on parallel and perpendicular lines, but we're also going to focus on a little bit later some vertical and some horizontal lines as well, and just kind of identify how they are interesting. So let's dive right in. Let's talk about a couple examples. It says, determine the equation of a line in slope point form. Good. We're going to have the slope and a point for slope point line form. And that passes through 1 comma negative 3 and is, so for the first one, parallel to this line, and for the second one, perpendicular to that line. So let's just first of all identify some things. When I hear parallel, I think, what is the slope of this current line? And the slope is 2/3. So what's parallel to a slope of 2/3? Well, parallel to a slope of 2/3 is 2/3. So the slope of our new equation, because it's parallel to this old equation, is going to be 2/3. And the point that we want it to go through is 1 comma 3. 1 comma negative 3, sorry. So all we have to do is we have to chug this into our slope point version of a line. Slope point version of a line is y minus y1 equals mx minus x1. So let's take all of the pieces of information. This is my y1. So we'll go y minus negative 3. Y minus negative 3 is actually y plus 3 times m, or equals m, which is 2/3 in this case, x minus, and our x1 is 1. So that's really all we had to do. Really the hard part here was to identify that what is parallel to this current line. Well, if it has a slope of 2/3, then parallel to that is 2/3. Okay, let's move on to the second example. If we want it to be perpendicular, there are two things I think about when I hear perpendicular. One is the negative of the current slope, and two, it has to be the reciprocal as well. So if it's currently negative, the negative of a negative is positive, and whatever number we get, we have to get the reciprocal of that. So what's the negative reciprocal of 2/3? Well, it's got to be negative because this is positive, and it's got to be the reciprocal, so 3/2. So our new slope is negative 3/2, but our point has remained the same. That's still 1 comma negative 3. So let's put this into our slope point form of a line. It's the same as this kind of this equation here, y minus y1. So y minus negative 3 is y plus 3 equals negative 3/2 x minus 1. So that's including our slope of negative 3/2 and our point of 1 comma negative 3. Let's try another example. So we want to determine the equation of a line in slope-intercept form. Well, when I think slope-intercept, I think y equals mx plus b. That passes through this point. It's giving us a point. So that's hinting at we're probably going to have to start with slope point version of a line that is parallel to that. This equation, you cannot immediately tell what the slope of this line is. It is possible if you're really good at rearranging equations in your head, but it's not possible if you're not good at rearranging equations in your head. So the first thing I want to do, I want to find out what the slope of this line is. So in order to find out what the slope is let's turn it into slope-intercept. So let's take this equation and let's get y by itself. In order to get y by itself, I'm going to subtract 7 and I'm going to subtract 2x. So 2x and 2x, 7 and 7. And I'm going to get y equals negative 2x minus 7. So the slope of our line that we're looking for has to be parallel to negative 2. Well, what does that mean? It means our new slope is negative 2. Perfect. So our slope is negative 2. Now, squiggly line. The second thing, we want to start off with a version of the line that we can actually use. We cannot go straight into slope-intercept form of a line. It's not possible. So, but we are given a point, and we found the slope. Well, that's hinting at getting slope point version of the line. So let's just put it into slope point form. Let's put it into slope point form. So y minus 4 equals m negative 2 x plus 3, because it's x minus negative 3, which is x plus 3. Good. So now that I have it in slope point form, what I want to do is I want to rearrange this so that we can put it in y-intercept. So I will distribute the negative 2. Y minus 4 equals negative 2x minus 6. And then in order to get y by itself, I'm going to add 4, add 4. So y is all by itself now. The negative 2x hasn't changed. And if I add 4, negative 6 plus 4 is negative 2. So we have now determined the equation of a line in slope-intercept form. Yes, this is y equals mx plus b. Good. Perfect. Another example, determine the equation of a line in slope-intercept form. Perpendicular, okay, that's a really important piece of information. Perpendicular to the line 3x minus 5. 3x minus 5 plus 11 equals 0, with an x-intercept of 3. What they're saying when they say an x-intercept of 3, I'm just going to draw a graph here. If it has an x-intercept of 3, I'm going to draw a random line with an x-intercept of 3. This is my x-intercept of 3. So this is 3, 0. That's what it's saying. So they're giving us a point, but they're disguising the point by saying an x-intercept of 3, but they are giving us a point. We're going to start off the same way we did last time. They're giving us a point, and they're telling us a slope. Okay, well, let's first find the slope of what this line is. So 3x minus 5y plus 11 equals 0. How I'm going to get y by itself is I'm going to add 5y, boom, boom. So I end up with 5y equals 3x plus 11. And then I'm going to divide by 5, divide by 5, divide by 5. So I get y equals 3/5 x plus 11/5. So what is the slope of this line? The slope is 3/5. Do we want to be parallel or do we want to be perpendicular to this line? We want to be perpendicular, so that means the new slope is actually negative 5/3. It's the negative reciprocal of whatever that number is. Perfect. So now that we know the slope, we can try and put it into slope-intercept form. but we can't start with slope-intercept form. We got to start with slope point form. So y, remember, minus our y1, which is 0. So y minus 0 equals m negative 5/3 x minus 3, which is our x value. This is y. We're going to distribute the negative 5/3 in here, so we get negative 5/3 x. And negative times a negative is a positive. 5 times 3 divided by 3 is just 5. The 3's end up canceling out. And lo and behold, we have found our way. We've stumbled into a slope-intercept version of this line. So the line in question, it says determine the equation of a line in slope-intercept form. Well, this is our slope-intercept form. It has a slope of negative 5/3, good, and it has a point of 3, 0, and when we rearranged, it's telling us that we have a y-intercept of 5. Perfect.